Hi, I'm Christopher, and in this short presentation I would like to introduce to you this work that was conducted jointly with the Ruhr-Universität Bochum and NTT Communication Science Labs. And in this work we are interested in sound event localization, which aims at finding the positions of active sound sources in the environment. An example is shown here in this image. So suppose we have a speaker located somewhere in a room and an additional loudspeaker also located in the room and a microphone array at some specific position in this room. What we want to do now is we want to estimate the directions of arrival, so the relative azimuth and elevation angles between sound sources in the environment and the respective microphone array. So several works have been proposed in this domain already. Here are shown some examples. So many works also proposed as deep learning frameworks. For example, here on the left-hand side, we see CELTNet, which is a system that can perform sound event localization as well as also sound event detection, which is a deep learning based framework utilizing recurrent neural networks. And as a standard deep learning framework, it does not have a probabilistic output stage. This is a little different in the middle, in the work shown here in the middle. So this is the dynamic stream wave backprop Kalman filter, which was proposed by our group also, which incorporates a differentiable version of the Kalman filter. Hence, this system has a probabilistic output where we can associate also estimation reliabilities with the individual DOA estimates. Here on the right-hand side, we see Adrenaline, which was recently proposed by our group, which is also a standard deep learning framework utilizing recurrent neural networks with an additional attention layer in a sequence-to-sequence fashion, like in natural language processing. So this also does not have a probabilistic output layer. So in the work we propose here, which we call PILOT, that stands for Probabilistic Localization of Sound with Transformers, we were thinking, well, what works good in natural language processing might also work good in sound event localization. So we propose a transformer-based sound event localization system that is shown here. And on top, to get also a probabilistic output, we put a linear Gaussian system that allows us to associate Gaussian variables with our output DOA estimates. So one example of this is shown here in this graph on the right-hand side. So to show you some key results, in a paper we show that PILOT consistently outperforms several baseline methods, both in terms of DOA error and frame recall, and that the probabilistic output stage also allows us to efficiently model the estimation reliability.